This is a fun little problem. We got Tarzan trying to cross a river by swinging from a 12-meter vine. His speed at the bottom of the swing as he clears the water is just at 5 meters per second. Tarzan has no idea that the braking strength of in other words, the tension that it can withstand of the vine is 1,000 newtons. I want to know what the net force exerted during the swing is, and will the vine break? First thing we're going to start out with is a little picture here. We got Tarzan, and a simplified Tarzan to a nice little circle here. There's Tarzan, and Tarzan is swinging. And at the bottom of his swing, we know his speed is 5 meters per second. That's the critical spot. So what we're going to do is we're going to do a force diagram at this spot. Here's Tarzan. We got FG. And we've got the tension force. So we know that the sum of the forces, let's do this over here. We know the sum of the forces is the same as the net force, also called the net force. And since he's kind of following a path, a circular path here, this would be the centripetal force, or force causing Tarzan to go in a circle. So that's going to be equal to mass times acceleration circular. Well, we know the mass of Tarzan. If we could just figure out the acceleration of Tarzan, then we can go ahead and figure out this net force exerted on during the swing. Well, we know that acceleration is equal to v squared over r for a circle. So we have that speed at 5 meters per second. So we can go ahead and figure that out. That's going to be 5 meters per second, and that's squared over the radius of the circle. Well, it's a 12-meter vine. That's 12 meters. So that's going to be the radius of my circle, right? 12 meters. So that means the acceleration circular is going to be equal to 5 squared divided by 12, which is going to be 2.08 meters per second squared. So I can go ahead and figure out that net force, because that's going to be, or that centripetal force, that's going to be equal to 87 kilograms, the mass of Tarzan, times that 2.08 meters per second squared. So that's going to be equal to 181.25 meters per second squared. All right, so that means that the sum of the forces is equal to force of tension minus force of weight, and that's going to be equal to 181.25. Oops, that's not meters per second squared. That should be newtons. Newtons. All right, so here's what we're going to do. We're going to solve for tension, because that's the second part. We already figured out the net force. That's here. So the second part is we're going to figure out the tension, because we want to see if the vine will break. If that tension is greater than 1,000 newtons, then the vine will break. So force of tension minus, well, the weight, that's going to be 87 times 9.8, which is, let's figure that out, 87 times 9.8, 852.6. 852.6 newtons. So it's going to be minus 852.6 newtons is going to be equal to 181.25 newtons. So I add this to both sides to solve for force tension. We get force of tension is going to be equal to that plus, oops, plus 181.25, and that's 1,033 newtons. Well, that 1,033 exceeds the 1,000 Newton braking strength, so that means that this will break. The vine will break.